Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Khalid Haziq. My matric number is J22A0119. For the question number 1, region A is bounded by x equal to 1 per 2, y power of 2 negative 3, and y equal to x negative 1. For the A, sketch the graph for the bounded area. For this question, we use the simple way to find the answer and sketch the graph. First, from the question, y plus 1 equal to 1 per 2, y power of 2 negative 3. 2y plus 2 equal to y power of 2 negative 6. And then after we make the calculation, we get the 0 equal to y power of 2 negative 2y negative 8. And then we factor and we get 0 equal to bracket y negative 4 bracket y plus 2 close bracket. So y equal to 4 and the second y equal to negative 2. After that, we plot the graph by using the points that we get. So it like the two curve with interest at the y equal to negative 2 and y equal to 4. Or if we need to the full coordination, that will be negative 1, negative 2 and 5, 4. And we get the graph with one straight line and the two curve. That's all for question A. For the question B is determine the area of A. For this question, we use the simple formula to get the answer. The formula is A equal to TC, open bracket right function, close bracket, minus open bracket left function, close bracket dy. And in other case, we don't have the function that is always on the left and the other is the right. So the equation of the line since is we need to be in a form x equal to f bracket y close bracket. But that is easy enough to do. For the area of A, for negative 2 bracket y plus 1 close bracket minus open bracket y per 2 y power of 2 negative 3 close bracket dy. After that, we make the calculation and we get for negative 2 negative 1 per 2 y power of 2 plus y plus 4 dy. After we make the calculation, we get bracket negative 1 per 6 y power of 3 plus 1 per 2 y power of 2 plus 4y for negative 2. So the answer that we get after the make overall calculation is 18 unit. That's all.
We have to sketch the graph for the volume of the solid by rotating the bounded of region Q. So we have the equation which is x equal to y power 2 minus 4 is the first one, and the second one is x equal to 6 minus 3y as equation number 2. So let y power 2 minus 4 equal to 6 minus 3y. So we get y power 2 plus 3y minus 10 equal to 0. So we solve y, so we get y equal to 2 and y equal to negative 5. So using the first equation, as x equal to y power 2, let y equal to 2 minus 4, we got 0. And the second one, x equal to 6 minus 3y, y we put it as negative 5, so we got 21. So the interaction point we got is x 0, y 2, and x 21, and y negative 5.
Question 2b. Prove the volume of Q is 31556 by 15 by using method of this. First thing, you have no formula by this method. So the formula you can see in the poster. Okay, we have A equal to negative 5 and B equal to 2. In the formula, you can get R in bracket y equal 24 minus in open bracket y power of 4 minus 4 close the bracket equal 28 minus y power of 2. Next, you can get R in bracket y equal 24 minus open bracket 6 minus 3y close the bracket equal 3y plus 18. For the two equation, you have to put in the formula. So the formula is v equal pi integral dc open the bracket r in bracket y close the bracket power of 2 minus open the bracket r in bracket y close the bracket 2 dy. Next, v equal pi integral to negative 5 open the bracket 28 minus y power of 2 close the bracket power 2, then minus open the bracket 3y plus 18 close the bracket power 2 dy. Next, v equal pi integral to negative 5 open the bracket y power of 4 minus 15/6 y power 2 plus 784 close the bracket power of 2 minus open bracket 9 y power 2 plus 108y plus 324 close the bracket power 2 dy. So you can get v equal pi integral to negative 5 open bracket y power 4 minus 65 y power 2 plus 108 y plus 416 close the bracket dy. So the last step, V equal pi, open bracket, 2 power of 5 per 5 minus 6, 5 in bracket 2 power of 3 per 3 minus 5, 4 in bracket 2 power of 2 plus 416 in bracket 2, close the bracket. Then minus, open the bracket, negative 5 power 5 per 5 minus 6, 5 in bracket negative 5 power of 3 per 3 and close the brackets. You can get answer V equal to 3. You can get the answer V equal 31,556 per 15 pi.
For 3a, to sketch it, as the given equation is x equal to bracket of y minus 2 power 2, so we expand it. We've got y power 2 minus 4y plus 4. So we got x 0, 4, y 2 and 0.
To determine the limits of integration for the curve defined by the equation x equals y2 squared when it intersects the x-axis. To find the values of y where the curve intersects the x-axis. To do this, we set x equal to 0 and solve for y. We start with the equation x equals y2 squared. To find the points of intersection with the x-axis, we set x to 0, 0 equals y2 squared. Now, we solve the equation by taking the square root of both sides. Square root 0 equals square root y2 squared. Simplifying further, we have 0 equals y2. To isolate y, we add 2 to both sides of the equation. 0 plus 2 equals y2 plus 2y equals 2. Hence, we have found the value of y where the curve intersects the x-axis, which is y equals 2. To determine the limits of integration for y, we consider the range of values where the curve intersects the x-axis. In this case, the curve only intersects at y equals 2. Therefore, the limits of integration for y will be from po, the lower limit, to 2, the upper limit. We found that the curve x equals y2 squared intersects the x-axis at the point y equals 2. Thus, the limits of integration for y are from 0 to 2. Formula. The formula for calculating the volume of an infinitesimally thin cylindrical shell is dv equals 2 pi, radius, height, dy, or, in the case of our specific problem, dv equals 2 pi xy dy. To calculate the volume of region B, we will use integration. We will integrate the expression 2 pi xy with the appropriate limits. The mathematical representation of our problem is as follows. V equals integral 0 to 2 pi xy dy, where 0 and 2 are the limits of integration, which define the bounds of region B. V equals integral 0 to 2 pi xy dy equals, insert the result of the integration here.
The integral expression we will evaluate is V equals integral 0 to 2 pi y2 squared y dy. Our goal is to simplify this expression and find the volume of the region using integration. To simplify the integral expression, we expand the term y2 squared to obtain V equals integral 0 to 2 pi y cubed 4y squared plus 4y dy. We will integrate each term separately. The integral of y cubed with respect to y is given by integral y cubed dy equals y to the power of 4, 4. The integral of minus 4y squared with respect to y is given by integral minus 4y squared dy equals minus 4y cubed, 3. The integral of 4y with respect to y is given by integral 4y dy equals 2y squared. Substituting the results of the integrations, our simplified expression becomes v equals 2 pi y to the power of 4, 4, 4y cubed, 3, plus 2y squared.
To evaluate the integral, we substitute the upper and lower limits of integration. V equals 2 pi y to the power of 4, 4, 4y cubed, 3, plus 2y squared, 2 pi 0 to the power of 4, 4, 4, 0, cubed, 3, plus 2, 0, squared. Simplifying the integral expression, we have v equals 2 pi 16 quarters, 32 thirds, plus 8, 2 pi 0 to 0 plus 0. V equals 2 pi 4, 32 thirds, plus 8. Continuing the simplification, we have v equals 2 pi 12, 32 thirds. V equals 2 pi 36 thirds, 32 thirds. V equals 2 pi 4 thirds. V equals 8 pi 3. After evaluating the expression, we find the volume of the given region as follows. V equals 8 pi 3 cubic units.